Assalamualaikum and good day everyone. So in this video we are going to discuss on the argument of the complex numbers. So the argument of z is the angle theta. So what is theta? So theta is defined from positive real axis and the complex numbers. Okay, before we can find the argument of the complex numbers or theta, we need to make sure that the given complex numbers must be in form of a plus bj or general form. So it must be in the form of z is equals to a plus bj. Okay, so if let's say you are given z is equals to, then you have fraction here. Okay, let's say you have 1 minus 2j over 1 plus 4j. Okay, so this is not in the general form of the complex numbers. So you cannot simply find the argument of z. Okay, so what you need to do first is you need to express this one into the general form of the complex numbers. We already discussed on how to express this one into the general form in our previous class. Okay, so now we will take a look at how to find the argument of z or the angle theta. Before that, take a look at this one. Okay, this is very important. Okay, after this you will have to use the argument of complex numbers to find z to the power of n or to find the roots of the complex numbers. So you really need to understand how to get the correct value of theta. Okay, so first, so I label this one as quadrant 1, quadrant 2, quadrant 3, quadrant 4. So as you can see in the step here, the first step, you need to identify the value of a and b. Okay, when you are given the value of z, let's say you are given z is equals to negative 1 plus 4j. So let's say, so you need to know which one is a, which one is b. Why? Because later you will substitute that value into this formula. So that's why you really have to know what is a and b. Okay, next, plot the graph. Okay, so let's say I have z is equals to 2 plus 3j. If I plot this one on the Argand diagram, I will have that complex number in the first quadrant, which is here. Why? Because I have a positive real axis here and a positive for the imaginary part. Okay, so you just have to plot, not to be like exactly to do the range, no. Okay, just for you to know which quadrant is your complex numbers. So what is your theta? So refer to the definition here. The theta is defined from positive real axis and the complex numbers. So from positive real axis, so this is the real part, isn't it? So this is the real part of z and this is the imaginary part of z. So from positive real axis to the complex number, so therefore this is your theta. Since your theta is in the first quadrant, so the value of theta must be between 0 and 90 degrees. So must be between here. Okay, so theta greater than 0 or less than 90. So what is mean with theta is equals to alpha? Okay, as you can see here, for step 3, I write it here, find the value of the reference angle theta. So how to find this one? By using this formula. Sometimes when you use tangent inverse b over a, you will directly get the value of theta, not the reference angle. Okay, when your complex numbers is in the first quadrant, so your theta is equals to your reference angle. Okay, let's say you have Z is equals to -3 plus 4j. So if you plot, so -3, so will be somewhere on the left hand side here, +4 here. Okay, so you know that your complex numbers lies on the second quadrant. So let's say here. Okay, so again, by using definition, your theta is defined from positive real axis to the complex number. From positive real axis to the complex number. So that is your theta. Okay, so as you can see here, when your theta lies on second quadrant, so the value of theta must be between 90 to 180. So how to get the value of theta? The value of actual angle. Okay, so 180 minus with the reference angle. So when you calculate the tangent inverse B over A, this is actually the reference angle. Okay, you will have the reference angle, which is here. Okay, as you know, from here to here, this is 180. So for you to get the actual angle here, so 180 must minus with the reference angle theta. Okay, let's take a look at the quadrant 3 here. So let's say you have your Z is equals to -3 minus 2j. So when you plot, you will have -3, so somewhere here, -2, so somewhere here. So the complex number lies on the third quadrant, which is here. So what is your theta? So again, we know that your theta lies on the third quadrant here. So from positive real axis to the complex numbers. So this is your actual angle. Okay, so as you can see here, since it lies on the third quadrant, so the value of theta must be greater than 180, less than 270. So what you are going to do to find the actual angle? So 180 plus the reference angle. So what is your reference angle? So by using this one, you will get your reference angle. Okay, so your reference angle is here. So for you to get the actual angle theta, so this one here will give you 180, so plus theta here. Okay, so the last one for quadrant 4, if let's say you have your Z is defined as 2 minus 3j. So if you plot this one, you will have it on the fourth quadrant here. Why? Because you have the positive for the real part and you have the negative for the imaginary part. So where is your actual angle? From positive real axis to the complex number. So this is your theta. Okay, so since your theta lies in the fourth quadrant, so your theta must be between 270 and 360. So greater than 270, less than 360. So for you to get the actual angle theta, so you need to do this operation 360 minus alpha. Why alpha? Okay, minus alpha here. So alpha is from tangent inverse B over A. So your alpha is here. So as we know, the complete circle here will give you 360. So minus this one, so you will have the actual angle. Okay. Okay, notice that in this step, I wrote here, ignore the negative sign. So what does it mean? Okay, let's say when you calculate tangent inverse B over A, and you have your reference angle, let's say you have negative. Okay, so for you to find the actual angle, we just take the value. So you just ignore that negative sign. Okay, let's consider if, let's say, your complex numbers lies on the second quadrant, and when you calculate the theta, when you calculate the reference angle, you have the value of negative 57.6, let's say. So for you to get the actual angle theta, so you have to ignore the negative sign here. Okay, so don't include the negative sign here. That's what I mean by this one. Okay, so therefore it should be 180. So here is minus, so you will have minus, so 57.6. Okay, for you to find the actual angle, you need to ignore the negative sign. So as you can see, in general, the reference angle is actually located between the x-axis or the real axis. For the first quadrant, your reference angle is here. For the second quadrant, your reference angle is here. So for the third quadrant, so this is your reference angle, and the last quadrant, quadrant 4, so this is your reference angle. Okay, so it's really important for you, because later on in the next subtopic, when we learn polar form of a complex numbers or exponential form of a complex numbers, you need to use your value of theta. Okay, so how to get your theta, the actual angle or the argument of complex number, by using this one. Okay, so please understand this quadrant. Okay, let's try this example. So I just skip the modulus part. Okay, find the argument for each of the following complex numbers. So I'm going to discuss only for B, E and F. Okay, so please try to do on your own for A, C and D. And for G and H, please refer to the video for you to get the answer. Okay, so now let's start with B. So for B, you are given your Z is equals to -1 plus 2J. So you know that your A is equals to -1 and your B is equals to 2. So when you plot these complex numbers on the Argand diagram, so it lies on the second quadrant. Why? Because you have the negative for the real part and the positive for imaginary part. So you will have here. So where is your actual angle theta? So from positive real axis to the complex number. So this is your theta. So you know that it lies on second quadrant, quadrant 2. So therefore your theta is equals to tangent inverse, so B over A. So what is your B? So tangent inverse 2 over negative 1. So this one will give you negative 63.43. But this is not yet your actual angle. This is your reference angle. Okay, so what is your theta? So since it is on the second quadrant, so the actual angle theta is equals to 180 minus alpha. So this one is your alpha actually. Okay, so here we just ignore the negative sign, so therefore you will have 180 minus 63.43. So therefore you will have your theta is equals to 116.57 degree. So your F Z is equals to 4J. Okay, as you notice that in my step, I asked you to plot first before finding the reference angle alpha. Why? If you calculate tangent inverse B over A for this one, you will have math error. Why you get math error? So if you plot this one, 4J, so there is no real value of Z. So the 4J, the complex numbers lies on the y-axis or on the imaginary axis. So what is your theta? So you already get your theta is equals to 90 degrees. Oops, sorry. So your theta is equals to 90 degrees. When it lies on the axis, so you don't have to calculate. Okay, because you already know the value of theta. So if let's say when you plot and you have here, so you know that your theta here is equals to 180. So if you plot and it lies here, so you know that your theta is equals to 270. So that's why I ask you, you really need to know how to plot. Okay, so I repeat for this one, why I have 90 degree here, because when I plot this one on the Argand diagram, it lies on the axis. Okay, so therefore we already know the theta is equals to 90 degrees. So for the last question, for E, so you are given your Z is equals to 1 plus 3J over 4 minus J. Okay, for this case, you cannot simply plot. You need to do something first. You need to express this one into the general form of the complex number, which is Z is equals to A plus BJ. Because from here, you don't know what is your A and what is your B. Okay, that's why you need to express in this form. Okay, so how to express this one? We already learned it in our previous class. So let us do this one quickly. So you will have to multiply with the conjugate of denominator. So you will have 4 plus J over 4 plus J. So when you calculate this one, expand the whole thing. So you will have 4 plus 13J plus 3J squared over 4 minus J squared. Sorry, this is 16. 16 minus J squared. Okay, as we know, J squared is equals to -1. So substitute this value right into here and here and simplify the whole thing so that you will have your Z is equals to 1 plus 13j over 17. So this is already in the general form of the complex numbers. So someone might ask, what is the difference between this one and this one? How come this one is in the general form of the complex number? Although as you can see, this is also a fraction. Same goes with this one. Okay, the difference is this is not in the form of general form because you have this one, negative j. Okay, so you need to eliminate this one. So that's why you multiply by the conjugate of denominator. So as you can see, when we apply this one, for the denominator part, you left with real value. So if you split this one, it's actually 1 over 17. So you can also write your z is equals to 1 over 17 plus 13 over 17 g. Okay, so when you plot the dot on the Argand diagram, you will have the complex number here lies on the first quadrant. Why? Because you have the positive real and the positive for imaginary parts. Okay, so this is your z. So therefore, what is your theta? So your theta is from here. So this is your theta. So by using theta is equals to tangent inverse b over a. So what is your b? 13 over 17 divide with 1 over 17. So therefore you will have your theta is equals to 85.60. So do you need to do anything? No. This is already your actual angle. Why? Because we already discussed earlier, when it lies on the first quadrant, your reference angle is equals to the actual angle. So that's why this is your answer. Okay, another way to check whether you are doing the right thing or not. So as you can see, when you plot, it lies on the first quadrant. So you have to make sure the value of theta must be between 0 to 90 degree. Okay, so let's say for the previous one here, since it lies on the second quadrant, so you know that the value of theta must be greater than 90, less than 180. So this value, the actual angle, is in between that. Okay, so that's all. So I really hope that you can understand this one. So please try to do on your own for the rest of the question. So as a conclusion, you need to know how to plot first. Okay, because if you plot wrongly, then everything will goes wrong. Okay, and remember, before you want to plot your complex numbers must be in general form. So that's all. I shall see you in my next video for more videos. So thank you and Assalamualaikum. Bye.